All right, 9.4, the culminating section of all of this material with quadratics. So we've learned several methods now. We've learned about factoring. We've learned about square rooting. Some of us have learned about completing the square. And we've learned about the quadratic formula. So the question we want to be able to answer is, how can you choose a method for solving a given quadratic equation? We have 3 to 4 methods. Some are better than others. We've talked about these briefly, but now let's throw all of these together and identify which one is best. So let's look at number 1 here. Go through a couple examples and then see if we can't see what makes one better than the other, and then we'll come up with those list of rules. So personally, I always try to start with factoring unless some other things are present. So when I see a trinomial, so 3 terms, so 7x squared minus 3x and minus 5, I want to try to factor. So I do my x. 7 times negative 5 is a negative 35. Then I get negative 3. So what multiplies to negative 35 adds to negative 3. So then we get 1 and 35. Well, that's 34. And then 5 and 7. Well, that's 2. So that doesn't work. So this is not factorable. We have a b term, so we cannot do square rooting. For those of us who did complete in the square, our b term is odd, and we have an a other than 1. So then from here, probably our best solution then is doing the quadratic formula. So we get negative b, which is a negative 3, plus or minus radical or square root, b squared, minus 4 times a, which is 7, times c, which is negative 5, all over 2a, which is 7. So simplify, and then this is x equals 2 negatives there make a positive 3. We get plus or minus. Negative 3 squared is 9. 4 times 7 times 5. Let me see. 4 times 5 is 20. 20 times 7 is 140. And then 2 negatives make it positive 140. All over 14. So then we get 3 plus or minus the square root of 149. All over 14. And then quick check, 149. So 149 doesn't break down, so then that is our final answer. So as we look at that, maybe try to factor it. Some of us may have looked at it and go, man, there's a lot of terms there as far as A, B, and C. I'm going to go ahead and go with quadratic formula. All right, let's go on to the next one. So trinomial, and our a is 1, so might make it easier to factor. So I get 6 on top, 7 on bottom. So it multiplies to 6 and adds to 7. Well, that's 6 and 1. Go ahead and draw our box. So we get x squared, 6x, x, and 6. Again, there's my x squared. My 7x is made of 6x and x, and then 6 is my 6. Then we look for our GCFs. So my GCF there is 1. GCF there is x, x, and 6. So then we get x plus 1, x plus 6, and that's equal to 0. Set each factor equal to 0 now. And I don't really need the parenthesis. X plus 1 equals 0. X plus 6 equals 0. So subtract 1. X equals negative 1. Subtract 6. And x equals negative 6. So in this case, factoring was very simple. Now, we could have done quadratic formula. Doing completing the square, for those who know it, our b is odd, so that would cause some issues. And we do have a b term, so solving by square roots would not be a good option. And let's look at number 3 here. So in this method, we can try to factor. Nice thing about factoring, especially when your a is 1, it's just a quick check. Is there anything that multiplies to 3 and adds to 8? And the answer to that is a no. We have a b term, so solving by square roots is not an option. So we have 2 options here. I'm going to do both because some of you guys have learned quadratic formula. All of you have learned quadratic formula, and a few of you have learned completing the square. So let's do quadratic formula first. So then we get x equals negative b, so in this case is 8, plus or minus radical b squared, which is 8 squared, minus 4 times a, which is 1, times c, which is 3, all over 2a, which again is 1. So simplifying, we get negative 8 plus or minus the square root of 64. 4 times 1 is 4, times 3 is 12, so minus 12. All over 2 times 1 is 2. Simplify, that gives us negative 8 plus or minus the square root of 52. All over 2. Then we break down 52. So we get 2 and 26, and then 2 and 13. There's our pair of 2's that we can pull out. So we get negative 8 plus or minus 2. And then we have a 13 left on the inside, so square root of 13 all over 2. Then we check, is there something that goes in all 3? There is, that's 2, so 2 goes in there, and we're left with a negative 4. Left with 1, and left with 1. So then we get x equals negative 4 plus or minus the square root of 13. All right, now completing the square with this method. So we get x squared plus 8x. We're going to move that 3 over by subtracting 3. And then what are we going to add here to complete that square? Remember, in order to get that, we go 8 or b divided by 2 and then squared. So that is 4 squared, which is 16. So I'm going to add 16 and add 16. This left side now factors for us to x plus 4 squared. And then negative 3 plus 16 is 13. Our squared term is now by itself, so we can take the square root. And we get x plus 4 equals plus or minus the square root of 13. X equals negative 4 plus or minus the square root of 13. Okay, and the last example here. So first off, right away, what I see is there is no b term there. So I'm going to solve with taking the square root. So then we want to get our squared term by itself. So I'm going to add 36. And we get 3x squared equals 36. Divide by 3. And x squared equals 12. Then we can take the square root, and x equals, break down 12, it's 4 and 3, 2 and 2, there's my pair, so I get plus or minus 2 root 3. Now, you could have solved this one by any of the other methods. If we did quadratic formula, your a would be 3, your b would be 0, and your c would be negative 36. This one is factorable as well. We would have had a GCF of 3. Then we get x squared minus 12, which then that is in difference of squares, so that one becomes a little bit harder. Completing the square doesn't really matter because we don't have that b term, but the easiest is solving by taking the square root. All right, so now let's look at what the advantages and disadvantages. So advantages of square roots is it's quick. There's nothing really new about it, but a disadvantage is it doesn't work if there's a b term. Okay, so that's the first thing I check for, eliminate. Hey, if there's a bx term, I can't do the square root. Advantages of disadvantages solving by factoring. So an advantage can also be fairly quick, especially if our a is 1. Disadvantage, though, is not everything's factorable. So then factoring doesn't always work. And then solving quadratic equation with the quadratic formula, the advantage is it always works. So regardless of the equation, you can use it. So you guys will get to the point where all you use is the quadratic formula, which is fine. The disadvantage is sometimes it can be long. Okay, and then for completing the square, advantage is it turns it into a square root problem, which can be fairly quick. Disadvantage is it can be long and works when bx is even and a is equal to 1. So a little more restrictions on that one. All right, so a couple practice problems here. I want you to do 6 and 7 on your own. We'll talk about those in class. And then number 8, choosing solutions to solve for a modeled problem. So Marco's throwing a tennis ball at a kite that is stuck 42 feet up in a tree, trying to knock it loose. He can throw a ball of velocity of 45 feet per second upward at a height of 4 feet. Will his throw reach the kite? How hard does Marcos need to throw the ball to reach the kite? All right, so as we look at this, we set this up and we get h of t is, remember, we're negative 16 t squared, and that's plus 45 t for our velocity, and then plus 4 for our starting height. Then they tell us the final height is 42. So I'm going to replace my h over here with 42. And then in order to solve, I need to subtract that 42 because we need to get it set equal to 0. And we get 0 equals negative 16 t squared plus 45t minus 38. Now as I look at that, I have a b term, so square rooting's out. That b term is odd, so completing the square is out. Factoring, those numbers are crazy big. There isn't really a GCF to lower it, so at this point I would just do quadratic formula. So then we get x equals negative b, which is 45, plus or minus the square root of 45 squared minus 4a, which is negative 16, c, which is a negative 38, all over 2 times negative 16. Then from there, I'd use a calculator to simplify that all down. So as we simplify what's under the radical, just looking at that, checking our discriminant, we get negative 407. Well, then that tells us that we have no real solutions. We may have 2 imaginary solutions, but no real solutions. Since this problem is taking place in the real world, he would not reach the kite. So then we need to adjust our velocity, which is 45, in order to get him to reach the kite. So in order to figure that out, we look at our radical, and the right side of it is negative 2,432. So the left side, our b squared, would have to be equal to or greater than that. So I'm going to take the square root of 2432, which gives me 49.32. So any value greater than that. So we'll go for a nice, so you could do that squared or anything greater than that. So the velocity equals to, needs to be greater than 49.32. And I guess equals 2 since we rounded up. Right, and so substitute that in, and that will give you what that is. All right, do the word problem number 9, and then you have your quizzes as well.